All right, so let's talk about megging compressors or megohmmeters or high pot testers or insulation meters. They're all the same thing and they all kind of do the same thing. Now, everybody manufactures one and they're all kind of a little different. I can't stand the brand that starts with an S, and I won't mention it, but when we talk about megging compressors, there's this big misunderstanding that somehow we're supposed to just show up to a job that has an E2, put our megohmmeter on the actual compressor itself, one leg on ground, one leg on the compressor, meg it, and then turn around and say, well, yep, she's grounded, and then order a new compressor and you're good to go. And that's not true. So let's talk about that. Everybody thinks that they can just go ahead and start megging compressors left and right, and that's how we diagnose a failed compressor. And it's not. I hate to tell you, megohmmeters are a maintenance tool. When I say a maintenance tool, they're designed to go through, send a specific amount of current through the windings, right? I've got a nice little Copeland compressor shell windings cut open. I've got a nice little K160 compressor cut open here too. They're designed to actually send a current, a certain specific voltage. We double the voltage on anything we meg. So if I have a 460 volt compressor like I do right here, I am going to apply 1,000 volts to it. And then not only am I going to apply 1,000 volts to it, but then I'm going to look at that megohm range reading and determine if it's a failed compressor or not. And I'll get to the reading numbers here in a second. However, there's other things that we have to consider when using a megohmmeter on compressors, on motor windings, to determine, is the reading actually accurate? And here's the thing. With a megohmmeter, it's a maintenance tool because it's designed to measure, right, the insulation resistance, how much electricity, how much voltage, how much current actually leaves those windings through the actual insulation back over to ground. And so we're supposed to use that tool to actually determine how much of those current, the whatever you want to call electrons, flow through that insulation back to ground, and take that reading and measure it over years, right? Year 1, year 2, year 3, year 4, year 5, and see and measure the insulation failure, right? The wear on the internal components of the compressor to the point where it's saying, okay, based upon this wear pattern, you've got another 5 years. Remember, compressors are wear components. It means that they get used and abused, and they have a specific amount of hour ratings that they'll last for. And so with a maintenance tool like a megohmmeter, right, not an actual service tool, it's designed to measure that resistance in that circuit over time and compare the readings to one another to determine the lifespan of that component, right? Has anything changed? Has the reading fell drastically over the past year? Maybe something's taken place to actually cause that reading to fall over those years and actually wear out the insulation, right? The insulation on these wires that you see here in the compressor, right? These are coated wires. You have this sheathing here, you have this banding here, you have these actual right here sheathing between the two here as well, and the same here with this Daikin compressor. You've got coatings, you've got coverings, you've got protectant. What happens to that stuff when it gets extremely hot, when you're not getting oil back to your compressor? Well, guess what? It wears out, it cracks, it degrades, and that's what a megohmmeter is designed to test. When do we not use a megger? We do not use a megger when a compressor is cold. Well, why is that, Roman? Because liquid refrigerant can be present in that compressor and can give you a false reading that a compressor is actually grounded or has a low megohm reading to determine and say, hey, this compressor is grounded. No, it's not. Is it cold? How long has it been sitting? Has the power been off to it? Does the crankcase heater work? Is the crankcase heater actually heating sufficiently enough to keep the compressor warm enough to actually use a megohmmeter to determine, am I seeing actual electrons flow to ground, or am I just looking at a compressor that's full of liquid refrigerant because it's 30 degrees outside and the unit hasn't run in 24 hours, right? So remember that these tests are here to help us and assist us in not only troubleshooting systems, but determining the lifespan, longevity, the wear properties of these pieces of equipment to determine maybe something might be going on between the last time I checked the maintenance to now, right? Now let's talk about reading numbers. Everybody's going to tell you that 1 megohm or less, and I live by this too, 1 megohm or less is a grounded compressor. It's an electrical short. And they say, well, Roman, what about anything less than 200? What about anything less than 100? And I used to be that kind of technician that would say, yes, anything below 200, that compressor's on its way out the door, right? Anything less than 100 and that compressor's on its way out the door. And here's the thing. It may be on its way out the door, but it's not an electrical short. It's not an electrical failure. I can almost guarantee you that 95% of those compressors that you have megged, that megged low, right, are mechanical failures. These are compressor components that when they don't get lubricated properly, the bearings within the compressor, right? The compressor housings actually wear out, right? What am I talking about? I'm talking about this section here wears out. It wallers out over time. And what happens to that? Then the rotor, right? Oh, here we go. Here's a rotor. A rotor actually starts to wear, not only at the top part, right, but also at the bottom part. This wear and tear on these actual rotors, and here's another one for discoloration, it causes it to wobble. It causes it to start to touch the surface. It starts to wobble and vibrate. It starts to cause excessive friction and heat. And that excessive friction and heat actually starts to cause it to wear even more and break down even more. Again, when we meg compressors and they meg low, and let's say that they overamp or they draw too much current, it's not an electrical short. It's not an electrical failure. It's a mechanical failure. That compressor has failed due to improper lubrication, due to insufficient refrigerant flowing back to keep the compressor cool, causing excessive overheat, and then causing metal components to warp and also change size and shape. Remember, these are small, little, tiny, perfect, round, right, designed to fit perfectly within those bearing housings. And excessive heat applied to these over time, especially spinning as fast as they do, it causes those bearings to warp, those sleeve bearings. And that results in, right, wear and tear internal to the compressor. So again, and I know I made a post about this a long time ago, but and on LinkedIn of all places too, where I said anything less than 100 megohms is a failed compressor. And that is not incorrect 100%, because remember, it means that there's a mechanical failure component where that compressor is being either slugged to death, it's not getting enough lubrication, that yes, over time, that 100 megohm reading is going to fall smaller and lower and lower and lower, and it eventually will lead to an either seizure or a ground out. That doesn't mean that it's an electrical failure, right? It's not a grounded compressor. It's not a shorted compressor. There is a difference. And again, this megohm meter that we use out in the field is not an end-all be-all tool. It's a meter, right? It's designed to allow you to take that reading and plug it into a number of other readings that you should be taking and evaluating on that site to determine if that compressor truly is failed, right? Or if that compressor has excessive wear and tear on it after only a few years. If I have a compressor that is warm, that has been tested on a 2-year-old system, right, and I've checked it, I've made sure everything looks good, everything else is great, and I check it and I meg it and it megs 50 ohms, right? 50 megohms, not 50 ohms, 50 ohms is grounded compressor. 50 megohms, then I'm going to say that yes, there's been excessive wear and tear internal to that compressor. Something is going on. I need to investigate. I need to find out why that reading is so low within the compressor in a brand new compressor. Most compressors, you should be OL. You should be 700 megohms or higher. You should be 600 megohms or higher, right? When we hit that 200 megohm reading and we fall below that, there are things that we should start investigating. Now, I'm not saying anything below 200 megohms means you need to change it out. It means you need to investigate why the reading is so low. Remember, nothing in VRF, VRV is a one-stop shop. We don't just say your discharge superheat's high, you got a failed compressor. Your suction superheat's low, you got a failed compressor. Your subcooling is crazy high, you got a failed compressor. No, we take all of these numbers, we take all of these readings, we take all of these measurements and we put them on a board. We put this puzzle together to create this beautiful picture that tells us, is it overcharged? Is it undercharged? Do they break piping discrepancies? Is there oil pooling in the system somewhere? Is it over-connected? Is the design of the system, after everything's been checked, is the design of the system just not the best, right? They're using it in a way that it probably won't work well, right? These are all things that we can identify by taking these things and plugging them together piece by piece, right? Don't ever let someone tell you that they meg the compressor and that it's bad without doing anything else, without investigating voltage, without telling you whether or not the compressor was hot. And I even prefer that my technicians tell me the temperature number, right? It's hard to just sit there and make up stuff on the fly. Our brains don't work that way. And so when someone just tells you that it was hot or that it was bad or that it looks good, these aren't actual measurements. Those are opinions, right? Tell me the number. What was the megohm reading number? What voltage was it set to? How long did it stay at that number when you held the button down? 5 seconds, 10 seconds, 20 seconds? What does that look like over time? What temperature was the compressor actually? Was it 150 degrees? Was it 100 degrees? Everybody's interpretation of hot is different, right? Somehow we kind of got into this lazy mentality that somehow we can just say good, bad, hot, cold, and that it's okay. Remember that we're technicians, and not only are we technicians, we're technicians of VRF, VRV, which means that we have to be very specific with the numbers and the things that we say, not only in our reports, but how we talk to our customers, and definitely when we diagnose things. So that's my rant for today. Stop megging compressors and condemning them, and actually do some investigation and understand when you should and when you should not mega compressor. Next video I'm going to make is about compressors and vacuums, and also putting them in refrigerant recovery mode and why they will blow the terminals out. So see you guys on the next one.